Okay, now coming to the what is a grammar. So already I told in the previous video in the theory of computation. So one is grammars, second one is the languages, third one is the acceptors. So these are very important. So mainly three categories in the whole subject. Okay, now coming to the what is the grammar. Okay, directly I am taking example. So first of all, a grammar is going to generate the language. Okay, it means generally it is going to generate strings. Okay, so a grammar is going to generate the strings. Okay, so collection of strings is called a language. Okay, that is what the meaning here. So generally grammar equal to I am having a four variables. One is v comma t comma p comma s. What is a v? Nothing but a set of non-terminals. In some textbooks they have given the name for v as the n. Okay, so n or v both are same. Okay, t equal to terminals, p equal to production, s equal to start symbol. So I am having so totally four variables. Okay, in order to explain about a grammar I am having the four characteristics are four elements. One is v comma t comma p comma s. Okay, I am taking example here. What is n comma rv, what is terminals, what is production, what is start symbol. Okay, so now here s equal to, sorry, how to read the grammar. So this part is called LHS, this part is called RHS. Okay, how to read a grammar. So this is the format of a grammar. Okay, so s tends to ASB, s tends to AB, B tends to B. Okay, in this way you are able to read the grammar, or you may read the grammar as S derives A S B, S derives A capital B. Okay, so B derives small b. Okay, in this way you are able to read. Now what is a V? Are non-terminals. So whatever the caps in the grammar, they are all the non-terminals. In this, what is the cap letters? One is S is a, it is a caps letter. So B is a caps letter. So that is called non-terminals, S comma B. Okay, that is called V here. Next one, what is the terminals other than the caps? Whatever the present in the grammar, they are called terminals, A comma B. Now what are the small letters? Small a, small b, small a, small b. You write in the t equal to a comma b, like that. Okay, that is about the terminals. Now what is a production? P equal to what? Production. Nothing but you give the name here and some numbering I am giving here. So 1 2 3. Okay, I am giving the name. I am giving some numbering for the rules, or sometime in some textbooks they may called, so p equal to rules they may call. Okay, so 1 comma 2 comma 3. Actually I have to write all these three rules here. So due to the place I am writing only the numbering here. Okay, you have to mention the all the productions in the p. Okay, nothing but to set of all the rules. Okay, so this is 1, this is 2, this is b, that is called so productions and a set of rules. Now what is s? Always, so s is the start symbol. So what is the start symbol? So top to bottom like this. So top to bottom like this. Okay, the first one. Okay, this is start symbol, even though both are the same. Okay, both are the same, so no problem. Okay, you may write this production here like this. Okay, so a b, this is a valid. Okay, that is valid. So what is the start symbol here? So top to bottom, this LHS is the start symbol. Okay, nothing but you write s here. So that is called so VTPS. Okay, what is the meaning of variables? So nothing but all the cap letters in the grammar, they are called variables, are non-terminals. T equal to what? Small a comma small b in this grammar. So other than the caps, remaining all are the terminals. What is a p? Set of all the rules, nothing but a rule 1, rule 2, rule 3. You write here. So what is a S? S is the, so top to bottom like this. Okay, you have to move like this. Okay, you have to move like this. So the first two rule, this LHS is the start symbol. Okay, that is all about the grammar. Now directly I am taking a concept. So what is a ambiguous grammar? This is very important question or a topic in the theory of computation. So what is a ambiguous grammar? First I am taking the theory, then I'll take some examples. If a grammar having a more than one leftmost derivation, or more than one rightmost derivation, or more than one parse tree, okay, so then the grammar is said to be the ambiguous grammar. Okay, now I'll take example here. Okay, so this is very basic example in so many textbooks they are taking. So E tends to E plus E, E tends to E star E, E tends to ID. Okay, so this is the grammar. So now I have to check whether the grammar is a ambiguous or not. How to check? What is the they have given? If I found more than one LMD, what is LMD? Leftmost derivation. If I found more than one RMD, nothing but a rightmost derivation. If I found more than one parse tree, then the grammar is said to be ambiguous. So generally, what is ambiguous? What is the meaning of ambiguity? Nothing but a doubt. Okay, so I'll take one example. For example, you assume this is a one road, so this is one crossroad, this is one more road. So here, now you are standing here. Okay, if you have any ambiguous, how can you move? Whether I have to take this path, whether I have to take this path. Okay, that is called ambiguity. Okay, so I have to choose this path, I have to choose this path, that is called ambiguity. Nothing but a doubt. Okay, so coming to the in the compiler design also theory of computation. Okay, there is a ambiguity. Okay, so we have to remove the ambiguity. It means what? We have to make the ambiguous grammar into the unambiguous grammar. That is what our intention. Now I'm taking the grammar. Now I am taking the string. Okay, how I have taken the string? By observation I have taken. Okay, so by observation I come to know that this is string given by the this grammar. Okay, now I am writing this is the string. Okay, by observation I got. So you start like this. Always you have to start from this. Mean nothing but you have to start from the rule one. Actually, see, by observation all the three same. So you write this as like this. E tends to, okay, E tends to E plus E, or E star E, or ID. Now this is you write like this. This is also valid. Okay, now what is the start symbol? This only start symbol. Okay, this only you start. You may take this one, or you may take this one, or you may take this one. That is your choice. Okay, it means that depends upon the solution or a problem. Okay, now for this example I am taking the this rule. So E tends to E plus E. Okay, next what I am placing in the place of capital E. Okay, in the place of capital E I am writing ID. That is what leftmost derivation. It means what? So in the left side I am replacing all the non-terminals with the terminals. Okay, so I'm telling one more time. In the left side I am replacing all the non-terminals using terminals. That is what? Okay, E tends to E plus E. Now what I am doing, in the place of capital E I am writing ID. Okay, now in the place of capital E what I am writing here? I am writing A star E. Okay, now tell me what I have to replace. I have to replace, in the place of this I am replacing a ID. Okay, next one what I have to replace. So in the place of E I am replacing ID. Now so I got a string. So this I want to derive. I have derived using what type of derivation? So using the LMD, using leftmost derivation. So ID plus ID star ID. Actually what is the ID here? Nothing but it is a identifier. Okay, it is an identifier actually. Now, so is there any chance? Okay, I have to check whether there is a one more chance. So there is a getting a chance of LMD. Okay, now I am taking E tends to E star E. Okay, so in the place of E star E, what I am taking, in this place of capital E, I am writing E plus E. That is what leftmost derivation. So here I am not replacing. First there is a chance here, I am replacing here. Then in the place of capital E, what I am replacing? I am replacing E plus E. Next what? So E tends to, in the place of capital E, I am replacing ID. Next, in the place of capital E, I am replacing ID. So in the place of capital E, I am replacing ID. So then what? So by observation, I am getting a one more leftmost derivation. Now what you say? So because I am getting a more than one leftmost derivation, this grammar is a ambiguous grammar. Very simple. So this grammar is an ambiguous grammar. Now what about RMD? Very simple. So opposite to this one. So now what you have to replace? In the place of this, you replace everything. Okay, so in the place of capital E, you replace everything. Okay, now we'll see here. So what is the string? Same string. Okay, ID plus ID star ID. Okay, same string I am taking here. Now so E tends to E plus E. Then what I have to replace? In the place of capital E, I am replacing E star E. Okay, now again what? In the place of capital E, I am replacing ID. Again what? In the place of E, I am replacing ID. Again in the place of E, I am replacing ID. So I got ID plus ID star ID, which is according to the given string. Okay, now is there any chance we have to get? See, no need to check all this one. You may check whether LMD or RMD or parse trees. Okay, no need to check all these things. You check any one. Okay, so you may check LMD, you confirm that yes, it is an ambiguous grammar. There is no need of checking again RMD. There is no need of checking again parse trees. Okay, for understanding purpose, I am telling all those things. Now you take, so E tends to E star E. Now what? So E tends to E star ID. See, so in the place of capital E, I am replacing ID. That is what. Okay. So and again what? Now in this place I am replacing E plus E. Again in the place of capital E, I am replacing ID. In the place of capital E, I am replacing ID plus star ID. Now by observation, I am getting two RMDs, rightmost derivation 1, rightmost derivation 2. Then what you say? So yes, the grammar is the ambiguous grammar. Okay, so because I'm getting the two RMDs and then two LMDs, the grammar is the ambiguous grammar. Okay, now we'll check for the parse trees. Okay, so what is a parse tree? Nothing but a syntax tree, like trees in the data structures. Okay, so I'm writing for the same string ID plus ID star ID. Now we'll see here. So E tends to E plus E. Then what will happen? E tends to ID. Okay, see, capital E, I am writing what? I am writing the, so I'm taking the grammar. So using this grammar. Okay, so using this grammar, I am drawing the parse tree. Okay, so E plus E. So that is what you have practiced. So again in the place of E, I am deriving ID. Okay, so now again in the place of E, what I am writing? I am writing the, so you have to use this grammar. Okay, so you have to use this grammar only. Hmm? So again E star E, E tends to ID, E tends to ID. So this is the parse tree one. Okay, next one what? E tends to E star E. So next in the place of capital E, what I am writing? I am writing E plus E. So E tends to ID, E tends to ID. This is the parse tree 2. Okay, that is what. So it means what? Again, by observation, I am getting a two parse trees. So nothing but a two syntax trees. Now what you say? So yes, the grammar is the ambiguous grammar. What is the grammar? This is the grammar which is ambiguous. Now what you have to make? You have to make a grammar unambiguous. So generally, okay, what is the problem? Okay, if I get like this, what is the problem? So technically, I am telling. So in the compiler design, in the phases of a compiler, in the second phase, okay, what is the output? What is the output of the second phase? Syntax tree actually. Okay, syntax tree. So if I get a two parse trees, Okay, the compiler have some ambiguity whether I have to choose this, whether I have to choose this. That is called ambiguity. So when there is ambiguity, the compiler is going to halt its execution, okay, or make you some wrong output. That is a problem. Okay, see, that's what I told here. So you have some doubt whether I have to move this path, whether I have to move this path. By mistake, if you choose this path, what will happen? Assume this is a wrong path. So then that will be leads to some wrong direction. Same as like this here also. So when there is a two parse trees, the compiler is having some ambiguity whether I have to choose parse tree 1, whether I have to choose parse tree 2. That is the problem. So what you have to do, you have to remove the ambiguity. You have to make the ambiguous grammar to the unambiguous grammar. That is our intention. Okay, so generally how to overcome the ambiguity. So one is the associativity, second one is the precedence. Okay, you know about the Bartmas rule. Okay, so Bartmas, okay, brackets, like that. Okay, order of execution, so division, multiplication, like that. That is what Bartmas rule, that is called so precedence. You know, in the C programming language, Bartmas rule. Second one, what associativity. Okay, I'll take small example. What is the precedence? So precedence here is, for example, I am having a string id plus id star id. Now you tell which first you have to execute. Okay, so compared to the plus star having the highest priority, then what I have to execute? First you have to execute this. Hmm? First you have to execute this, then you combine this result to the id plus some result. So this is called the precedence. Okay, now what is the associativity? Okay, now what is the associativity? Now see here, if I have a string, okay, so if I have a string, if I have the string id plus id plus id, see, plus and plus have same operator. It is plus is arithmetic operator. Here also plus is arithmetic operator. Which one first you have to execute? From the programming rule you have to understand. So which plus first I have to execute? From the programming rule, always, generally how the program executes, already you know. So the program executes from top to bottom, like this, and then L to R. This is the procedure. Okay, so that is what your program is going to execute, like this: top to bottom, L to R, left to right. It means, so whatever the first place is coming, okay, this I have to first execute. That is called left associativity. You have called. Okay, so you have to call it as the left associativity. So even though I am having the same priority operators, so this is the first I have to execute, which is called left associativity. So it means left associativity leads to the left recursion. That is, I'll tell later what is the concept of recursion, but I'll give some hint for that also. It means left associativity, okay, which leads to the left recursion. Okay, now you see. Now I am taking the this string for my convenient, id plus id plus id. Okay, left recursion means, listen. So these two must be same. Okay, so these two must be same. This and this. So this is LHS. This is RHS. So this is called left recursion. Then what you update the, you update. I'm writing here. You update e tends to e plus e to this side. Then what? This is C. This is not a left recursive. This is not a right recursive. Why? Because you may say this is same. Then this is a left recursive. Again, this and same. What you say? This is right recursive. Any one can be there, not both. So what is my answer? Actually, my answer should be the left recursion. So you update this rule production as to like this. So e tends to e plus id, e tends to id. That is what. Now I am taking one more example here. Now id star id. Okay, so id star id. Then you tell star and star having the same priority. Yes. So what you have to execute? You have to go for the, so associativity rule. left associativity rule. Okay, it means what? You update, so I'm writing here E tends to E star E, okay, to this production. Then this is the left recursion. Okay, why? Because from the left associativity rule I am updating this to the this one. Okay, this one. Then what you write? Finally I am updating E tends to E plus id. I'm writing here one more time. E tends to E star id. Finally it tends to id. This is what I'm getting. Okay, now this is modifying as same. Both are same. See here, both are same. Simply I am adding a new non-terminal for my convenient. Okay, see, left recursion is there, left recursion is there, so that is one. Okay, so it means what? E tends to E plus t, t tends to t star f or f tends to id. Now you check. Okay, now this is the unambiguous grammar. Okay, so this is the unambiguous grammar here. Okay, now uh, now I will take so example. Sorry, now I take example. So here, so id plus id star id. Now for this I am generating the tree. So first, I'm writing here one more time. So E tends to E plus t or t tends to t star f or f tends to id. So why I am writing like this, I'll tell. Listen. Now this is the unambiguous grammar. Now okay, now I want to generate this string using this grammar. I'm So you may take lmd, you may take rmd. I'm taking the parse tree for convenient purpose. So E tends to E plus t. Always you have to start from this rule only. Okay, next I have to start like this, next I have to start like this. Okay, that is what. Okay, now E tends to E plus t. Now in the place of E, what I have to get? I have to get id, so that E tends to, I am bypassing to the t. From t to the I came to here. Okay, okay, I'll take here. So from E tends to t, I am bypassing to the t. Again, I will come to here. So from t to I am bypassing to the f. So f tends to id. That is what here. E tends to t, t tends to f tends to id. Okay. Now what is the pending? So t. Now in the place of t, what you write? You write the t star f. You write t star f. Then so t star f. So bypass t to the f to the id. T to the f to the id. F to the id. Okay, see, by observation I am getting only one parse tree. Okay, so this is the how to write the unambiguous grammar. Okay, this is how to write unambiguous grammar. Okay, for example, you may have some doubt. So if I have the this if I have the I am having an operator like this. So 3, okay, 3 square, okay, like this. So this is what gives rise to operator. Okay, gives rise to. Generally, first what you have to execute. So generally, so 2 square. Okay, then like this. Okay, generally, so 3 like this, like this. First I have to. Okay, I'm writing here 3 2 square. Generally, first what you have to execute 3 2 square, which is equal to 3 power 4. Now what you say? This is a right associativity. This is a right associativity. Then you update the program, grammar to like this. Okay, simply what I am writing here. So I am adding one more rule here. So f tends to, this is right associativity. Then so then what will happen? G gives rise to f, G. So then G tends to id. See, now this and this are not same, they are different. What are same? This and this are same. Why? Because it is right associativity. Okay, that is what left associativity, right associativity. Okay, now take one more example. Okay, So S tends to SS, S tends to left parenthesis S, right parenthesis, S tends to epsilon. And one more thing, I will tell how to print the how to print this output onto the screen. Okay, so you start like this. When you see terminal, you write in the output. Again plus, again ID, again star, again ID. Okay, again we have to go like this. So this is output from for the tree. Okay, in this way you have to print the output. You have to move top to bottom, L2, or get the output. Okay, now take one more example here. So now convert the grammar into unambiguous grammar. Now I am taking, so by observation I am able to get strings like so this is one string I am able to get from this grammar. Okay, I am doing here. So or I may get the string like this. So like this. Okay, look, double parenthesis, etc. Okay, now I'm checking whether the grammar is ambiguous or not. Now I am checking for this. Now you see here, so S tends to SS. So this I have taken. Next one, what in the place of S, what I have taken? I have taken this one. So this I have taken. Okay, this I have taken. Okay, now sorry, for this I am writing. Okay, so for this I am, this is the tree. Okay, so again what in the place of S I am taking one more time this one, this rule. Then what will happen? So then like this I am getting S tends to epsilon, S tends to epsilon. Now if you trace this string, what I will get? Okay, I will trace the output. So start like this, left parenthesis, I am getting output here. Okay, again one more left parenthesis, right parenthesis, right parenthesis. Okay, now you got the output. Okay, this is the string actually. Now I'm getting one more parse tree. So S tends to SS. Now in the right S I am placing the, taking this one. Okay, so this one I'm getting, see by observation. So this is a one parse tree, this is one more parse tree. Because I'm getting a two parse trees, the grammar is a ambiguous grammar. Okay, in this way you have to check. Now take one more example. So for this, okay, for this, okay, these are the trees. Now what? S tends to SS. In the place of S you write this one. So in the place of S you write this one. So S tends to epsilon, S tends to epsilon. Then what will be the string? Like this, like this. Okay, so again what I'm taking, S tends to SS, S tends to epsilon, S tends to, again I'm taking SS. So there is a possibility, so there is a possibility. So I'm, what is the string I'm getting here? I'm getting string like this, like this. So for this also I'm getting a two parse trees. No need to check for two strings, you check for one string and you confirm that the tree, the grammar is a ambiguous grammar. Now how to overcome? So how to overcome means, okay, so I have taken this string. Okay, this string uh, for my answer. Okay, now you tell me, I am having a two brackets, which one first you execute? Brackets same, so the first left bracket you have to first execute. That is what our idea, left associativity. Now you come to the answer. Now what I'm taking, I'm updating the grammar like this. Okay, I'm updating the grammar like this. See S tends to, okay, so I'm updating the grammar. First right parenthesis, I mean first bracket I am executing first like this. Now again I am writing S here. Okay, it means what? I am concatenating S. See, very simple here by observation. So actually I'm taking here, so which one first I'm executing? This one. So I write bracket, S will be there from the grammar. So if I want to get this one more bracket, what I have to write? You write one more s, simple s, that is enough. So s tends to epsilon. So this is the unambiguous grammar for the given grammar. Now you try. Okay, so for this I am taking here. So s tends to, in the place of yes, you take this one. Okay, so left parenthesis yes, right parenthesis, and then yes. Okay, now again what, in the place of s you take same. So this one, left parenthesis s, right parenthesis s. So when you trace this one, I am getting this as the output. See, I am getting only one parse tree. Okay, same for the string also, I am getting only one parse tree. So this is the unambiguous grammar. So how I got this answer? Very simple. So from this, okay, from this, okay, actually this one first I have to execute, left one, then I write like this. Then if I want to get one more bracket, what you write? You write simple s, that is enough. Okay, okay, that is enough. Then you will get the answer. Wherever there is s, finally you place epsilon, you place epsilon. Okay, in this way. Okay, that is all about the unambiguous grammar. This is a very important topic which will come in the exam. Okay.